consider target costing. Target costing. My lecture today shall cover the meaning of target costing and methods used to determine the target cost. So, what do you mean by target cost? Target costing involves setting a target cost by subtracting a desired profit margin from a competitive market price. When you subtract the desired profit margin from the competitive market price, it will give us what is called the target cost. That is, subtracting the desired profit margin from a competitive market price. Target cost is used to determine the market price for a new product in which market research is adopted as a basis for measuring performance. It is used to determine the market price for a new product in which market research is adopted as a basis for measuring performance. Target costing is the opposite of the conventional cost plus pricing. Opposite of the conventional cost plus pricing. Now, determination of target costing or target cost. You start with the competitive market price, you less the profit margin, then it will give us the target cost. Step used in deriving a target cost. Number one, determine the target price which customers will be willing to pay. Determine the target price which customer will be willing to pay for the product. That is the first step. You determine the target price which the customers will be willing to pay for the product. The second step is to deduct the target profit. That is, the first thing, you determine the market price that the customers will be willing to pay. The second one is to deduct the target profit margin from the target selling price. You deduct the profit margin from the target selling price, then you get the target cost. Then estimate the actual cost of the product. That is the third step. You estimate the actual cost of the product, and finally, if the estimated actual cost exceeds the target cost you have obtained here, if the estimated actual cost exceeds the target cost you have obtained here, then consider the way to bring down the actual cost to the target cost. That is, you try to close the target cost gap. You try to close the target cost gap by bringing down the actual cost to the target cost. Those are the steps for solving problems involving target costing. So we want to take examples. Example 1. Company C is currently considering expansion into manufacturing 2 new products, a printer and a digital camera. Company C normally uses a pricing policy of a 10% markup on the standard prime cost. Prime cost on its products. However, as both the printing and camera markets are highly competitive, the finance director is considering using a target costing approach, but want to retain the same markup. Printers. The maximum price the market will support is $200 per unit of the name printer. 60% of the direct cost of each printer is expected to be polymer. Digital camera. 40% of the direct cost of each digital camera is expected to be software necessary to make one digital camera is currently $76, which has been built into the budget. On this basis, Company C has determined that the cost gap between the budget cost per digital camera and the target cost per digital camera is $23.70 required. What is the target cost of the polymer used in manufacture of printers? So now our focus in A is on the printers. A. So I've told you that target cost, you want to determine the target cost. Target cost. What is the target cost? That is the question of the polymer used in the manufacture of printer. What is the target cost in the requirement A of the polymer used in the manufacture of printers? So that is the requirement in A. I've told you that the target cost should be the selling price. The maximum price the market will support is $200 per unit. That is the market price. That is the selling price. You have selling price of $200. Selling price of the printer is $200. We now less profit margin. Profit margin. Now, if you go back to the question, a printer and a digital camera, company C normally uses a pricing policy of a 10% markup on standard prime cost. Markup on standard prime cost. Prime cost and direct cost. So, it is markup we are given of 10%. You have to convert the markup to margin. If markup is 10%, mark up, which is 10%, which is 10 over 100. Therefore, margin, to convert markup to margin, you add the numerator to the denominator. The numerator is 10. You add it to what you have in the denominator. So it will now be 10 over 110. So now, our margin is 10 over 110 times 200, the selling price. That will give us the profit. 10, 200 times 10 divided by 110. That will give us 18.18. Our profit is $18.18. When you less the profit from the selling price, then you will arrive at the target cost, which is 181.82. That is the target cost. Target cost is 181.82. Now, since you have got the target cost, but the requirement is what is the target cost of the polymer? The target cost of the polymer used in the manufacture of printers. The target cost of the polymer used in the manufacture of the printer. Now, the question says that the maximum price the market will support is $200 per unit of the new printer. 60% of the direct cost of each printer is expected to be polymer. All these target costs, they are prime cost. The prime costs are direct cost. Now, 60% of the target cost. Now, 60% of the target cost are 60% of the direct cost of each printer is expected to be polymer. So that is target cost associated with the polymer now. Polymer. That is 60%. 60% of $181.82. So when you calculate 60% of that, it will give us $109.09. That is the amount associated with the polymer. So that is the requirement in A. B. Assuming that target costing principles are adopted. Assuming that target costing principles are adopted, what is the maximum selling price that company C can charge per digital camera? So now the requirement in B is on digital camera. That means our focus should be on digital camera here. So that is B. You have to calculate the selling price. So the selling price. Don't forget, their policy is 10% markup on the standard prime cost. Now let's go back to the digital camera. 40% of direct cost of each digital camera is expected to be software necessary to make one digital camera. 40% of direct cost of each digital camera is expected to be software necessary to make one digital camera. One digital camera is currently $76. If 40% of direct cost of each digital camera is expected to be the software necessary to make one digital camera, and it's currently $76, which has been built into the budget. On this basis, company C has determined that the cost gap between the budget cost per digital camera and the target cost per digital camera is $23.70. Now we want to determine the direct cost. 40% of direct cost is $76. So if 40% is $76, to get 100% now, that is the total direct cost now. Total direct cost will be 76 divided by 0.4. That is 40%. 40 divided by 100 to give us 0.4. 76 divided by 0.4, that will give us $190. Alternatively, if 40% is 76, what we need is 100%. 100% is unknown. So to solve for x now, which is 100%, you just cross multiply. So 76 times 100, it will be 7,600. 40 times x will be 40x. 40x is 7,600. To get the value of x, we divide both sides by 40. Divided by 40. So that will be 7,600 divided by 40. And that will give us 190. And if you don't want to do it that way, if 40% of direct cost is $76, 1% now of direct cost will be 76 over 40. If 1% is 76 over 40, 100% of direct cost, 100% direct cost will be 76 over 40 times 100. 76 over 40 times 100 will give us $190. So whichever way you like, you may choose to use it. Now, you have got the total direct cost, and that is $190. And 40% of direct cost of each digital camera is expected to be software necessary to make one digital camera. It's currently $76, which has been built into the budget. On this basis, company C has determined that the cost gap between the budget cost. Notice direct cost is the budget cost. Direct cost is what you have in the budget. The budget cost is $190, and which is direct cost $190 per digital camera, and the budget cost per digital camera, and the target cost per digital camera is $23.70. I repeat, on this basis, company C has determined that the cost gap between the budgeted cost per digital camera and the target cost, the cost gap between the budgeted cost and the target cost, and our budgeted cost is the direct cost. The cost gap, the amount by which the budgeted cost exceeds the target cost, is $23.70. That is the cost gap. So you now less the cost gap, less the cost gap of $23.70. If you less that from 190, then you arrive at the target cost. The target cost will be 190 minus 23.70, and that will give us 166.30. This is the target cost. Now we've got our target cost, and go back to the requirement in B. Assuming that the target costing principles are adopted, what is the maximum selling price? You have to determine the maximum selling price that the company C can charge per digital camera. This is the target cost, and you used to add a profit markup of 10%. Then you add profit markup of 10%, which is 10 over 100 times 166.30. 10% of that will give us $16.63. So when you add it to 166.30, then we have 182.93. This is the that's the maximum selling price required. So that is the selling price. That is the solution to the first question. So this second question is taken from ACCA past examination question. Camco manufactures webcams devices which can provide live video and audio streams via personal computers. It has recently been suffering from liquidity problems and hopes that this will be eased by the launch of its new webcam, which has revolutionary audio sound and visual quality. The webcam is expected to have a product life cycle of 2 years. Market research has already been carried out to establish a target selling price and projected lifetime sales volumes for the product. Cost estimates have also been prepared based on the current proposed product specification. Camco uses life cycle costing to work out the target cost for its products, believing it to be more accurate to use an average cost across the whole lifetime of a product rather than potentially different costs for different years. You are provided with the following relevant information for the webcam. Projected lifetime sales volume is 50,000 units. Target selling price per unit, and that is $200. Target profit margin, 35% of selling price, and that is $70. Estimated lifetime cost per unit, see note below, and that is $160. Note estimated lifetime cost per unit, and we have manufacturing cost, which comprises direct materials, bought in parts, which is $40. Direct labor or $26. Machine cost of $21. Quality control cost of $10. Rework cost $3. Total $100. No manufacturing cost. We have product development cost, and that is $25. Marketing cost of $35. Total $60. Estimated lifetime cost per unit is $160. The average market price for a webcam is currently $150. The company needs to close the target gap of $30 between the target cost and the estimated lifetime cost. The following information has been identified as relevant. 1. Direct material cost. All of the parts currently proposed for the webcam are bespoke parts. However, most of these can actually be replaced with standard parts costing 55% less. However, 3 of the bespoke parts, we currently account for 20% of the estimated direct material cost, cannot be replaced. Although an alternative supplier charging 10% less has been sought for this pass. 2. Direct labor. The webcam uses 45 minutes of direct labor, which costs $34.67 per hour. The use of more standard pass, however, will mean that while the first unit will still be expected to take 45 minutes, there will now be an expected rate of learning of 90%, where B is minus 0.152. This will end after the first 100 units have been completed. 3. Reward cost. This is the average reward cost per webcam and is based on an estimate of 15% of webcams requiring rework at a cost of $20 per rework. With the use of more standard pass, the rate of rework will fall to 10% and the cost of each rework will fall to $18 required. Recalculate the estimated lifetime cost per unit for the webcam after taking into account point number 1 to 3 above. That is the question. So, we want to prepare the revised target cost. Solution. We have revised target costing, revised target cost. Then the target cost comprises 1. Manufacturing cost. Manufacturing cost. Then we have manufacturing costs. Manufacturing costs comprises, we have direct materials, bought in part, which is $40. Direct materials, let's have that as working 1. Now let's go through the note 1. Direct material cost. All of the parts currently proposed for the webcam are bespoke parts. However, most of these can actually be replaced with standard parts costing 55% less. Bespoke parts can be replaced with standard parts costing 55% less. However, 3 of the bespoke parts, which currently account for 20% of the estimated direct material cost, cannot be replaced. Non-replaceable part is 20% of the estimated cost. Although an alternative supplier charging 10% less has been sourced for this part. We have the bespoke part, that is direct material, working 1, will be divided into 2. We have they have direct materials. We have replaceable part, and non-replaceable part. We were told that, however, 3 of the bespoke parts, which currently accounts for 20% of the estimated direct material cost, cannot be replaced. The part that cannot be replaced, non-replaceable part, is 20% of the estimated cost, which is 20% of the estimated cost. Estimated direct material cost is $40. Estimated direct material cost is $40. You have 20% of $40, and that will give us 20% of $40. That will give us $8. $8. That is for non-replaceable part. That means the remaining 80% will be for the replaceable part. 80% of $40, and that will give us $32. Replaceable part will account for $32 of the estimated cost. Now let's go ahead. for the non-replaceable part, 20% of the estimated direct material cost cannot be replaced, although an alternative supplier charging 10% less has been sourced for this part. So the actual cost of non-replaceable part, actual cost for non-replaceable part now, replaceable part, supplier, alternative supplier source for is charging 10% less. So it's charging 10% less. That is, the non-replaceable parts cost $8, and if that one is charging 10% less, that means that one will charge 90% of the estimated cost. 90% of $8, and that will give us $7.20. Then for replaceable part now, replaceable parts, direct material cost. All of the parts currently proposed for the webcam are bespoke parts. However, most of these can actually be replaced. Replaceable part is 80%, with standard parts costing 55% less. Replaceable part costs 55% less, and that is estimated to be $32. And if it is 55% less, we have 1 minus 0.55, 55%. That will give us 45%. 45% of $32. That will give you the actual cost of the replaceable part, and which is 14.40. So if you add it to 7.20, that means direct material cost is 21.60. That is the actual direct material cost, 21.60. So you substitute for that here. So 21.60 is the actual direct material cost. Now we've done with that. The second one is direct labor. Direct labor, and that is given to be $26. Now let's check notes on that. Note 2, direct labor cost. The webcam uses 45 minutes of direct labor, which costs 34.67 per hour. The use of more standard parts, however, will mean that while the first unit will still be expected to take 45 minutes, there will now be an expected rate of learning of 90%, where B equal to minus 0.152. This will end after the first 100 units. The learning process will end after the first 100 units. After the first 100 units have been completed. So this note 2 require the knowledge of learning curve. So for better understanding, I will advise you to watch my lecture on learning curve. So direct labor cost. Direct labor. So let's have that as working 2. Direct labor. Using algebraic method of learning, we have y equal to ax raised to power b, where y is the average cost of producing the cumulative output. Ya is the time for producing the first unit of the first batch. Yx is the cumulative output over number of units in the first batch, and the b is logarithm of learning rate over log 2. So our A, I said it is the time spent in producing the unit in the first batch, the first unit. Now let's go through the question. Direct labor cost. The webcam uses 45 minutes of direct labor, which costs 34.67 per hour. The use of more standard parts, however, will mean that while the first unit will still be expected to take 45 minutes, the first unit will take 45 minutes. That means A is 45 minutes. There will now be an expected rate of learning of 90%, where B is minus 0.152. This will end after the first 100 units have been completed. That means X will be 100. 100 over 1. That is cumulative output over number of units in the first batch. The units in the first batch is 1. Raised to power B. Our B is logarithm of learning rate over log 2, and that has been given as minus 0.152. So we have minus 0.152. So you have 45 times 100 raised to power minus 0.152. So if you depress your calculator, 100 exponential minus 0.152, and that will give us 0.496592. So we have 45 times 0.4965922321. So if you multiply that by 45, then you have what the y equals to 22.34665 minutes. Now the next step is to calculate the cumulative hours or cumulative minutes, cumulative time of producing the 100 units. Total time spent in producing 100, in producing the first 100 units, and that will be 100 times 22.34665. If you multiply that by 100 times 100, then you have that to be 2,234.66. Let me approximate to 2 decimal places, 67 minutes. 2 decimal places. That is the time spent in producing the first 100 units. Then, and you were told that the learning process will stop at the completion of the first 100 units. That means, the total cumulative output is 50,000. That means it is the time spent in producing the 100th unit that will be spent in producing any unit after the first 100. That is from 101 till 50,000. If you subtract 100 from 50,000, then you'll be left with 49,900 units. That means the time spent in producing the 100th unit will be spent in producing the remaining 49,900 units. So in that case, you will need to calculate the time required to produce the 100th unit. And to calculate that, you will first of all need the time required to produce the 99th unit. The first 99, let me say the first 99 units. So time required in producing the 99 units rather, the first 99 units. Your A is still 45, while your X will now become 99 raised to power B, which is minus 0.152. 99 raised to power minus 0.152, that will give us, you have 45 times 0.49735151, multiply by 45, that will give us y equal to 22.38081844 minutes. What is the total time required to produce the total of 99 units? Time required to produce the first 99 units. That will be 99 times 22.38081844. So times 99. That will give us 2,215.66 34.70 minutes. That is the time required to produce 99 units. Then what will not be the time required to produce the 100th unit? Time required to produce the 100th units. It will not be the time required to produce the total 100, and which is 2234.67. 2234.67 minutes minus time required to produce the 99th unit, which is 2215.70 minutes. If you now subtract that, 2234.67 minus 2215.70, that will give us 18.97 minutes. 18.97 minutes. 18.97 minutes. Yes, after that, you now want to calculate the total time required for the total of 50,000 units. Time required for 50,000 units, and that will be time for the first 100. Time for the first 100 units, and that is the first 100 units. Take 2,000. Time spent in producing the first 100 units. Take 2,234.67. Time is in minutes. Then you want to produce the total of 50,000. If the first 100 takes you this, then the remaining 49,900. Time for the remaining 49,900 units now will be 49,900 times the time for the 100th unit, which is 18.97. 18.97. So that will give us times 49,900. That will give us 946,603 minutes. 603 minutes. Then when you add it to the time for the first 100 plus 2,234.67, that will give us 948,837.67 minutes. That is the estimated time or total time required for the 50,000 units. In minutes. This time is in minutes. Now, if you want to take it to hour now, you divide it by 60. 60 minutes make 1 hour. Now, let's go back to the question now. If the rate, direct labor cost, the webcam uses 45 minutes of direct labor, which costs 34.67 per hour. That will cost 34.67 per hour. Then total direct labor cost now. Total direct labor cost now. For the 50,000 units, you know, it costs 34.67 per hour. We have 34.67 times 948,837.67. You know, this is in minutes. You have to convert it to hours since the rate is per hour. Then divided by 60. So 34.67 34.67 times 948,837.67 divided by 60 minutes, and that will give us 548. That is total direct labor cost, 548,270.03. Then to calculate the direct labor cost per unit, direct labor cost per unit, that will be 548,270.03 divided by 50,000, which is the total output, divided by 50,000, and that will give us 10.97 approximately per unit. So direct labor working 2, which is 10.97. That is direct labor cost per unit. Then we also have machine cost, and that is $21. There are no notes on machine cost, so you use that directly. Machine cost, which is $21. Then we also have quality control cost, which is $10. Quality control cost, $10. Quality control cost, $10. There is no note on that. Then we also have rework cost. Rework cost, and we have that in note 3. Rework cost. Let's have that as working 3. Rework cost, working 3. Working 3. Rework cost. Now back to the note. Rework cost. This is the average rework cost per webcam, and is based on an estimate of 15% of webcam requiring rework at a cost of $20. This estimated rework cost of $3 is obtained by calculating 15% of the total estimated output of 50,000, or total lifetime cam of 50,000. 15% of 50,000 times $20. That is what gives us, that will give us 150,000. If you now divide the 150,000 by the 50,000, it will give you the average cost of $3. So now, with the use of more standard parts, the rate of rework will fall to 10%. So rework cost 10% of 50,000 times, and the cost of each rework will fall to $18 times $18. That will give you the total cost. Then you now divide it by the total output of 50,000. So we have 10% of 50,000 times 18, then divide the result by 50,000, then you have it to be $1.8. So the work cost is $1.8. That is, when you add it up, that will give you the total manufacturing cost. 1.8 plus 10 plus 21 plus 10.97 plus 21.60. That will give us 65.37. That is the total manufacturing cost. Aside manufacturing cost, we also have non-manufacturing cost. Non-manufacturing cost. Non-manufacturing cost, which is, it comprises production development cost of $25. There are no further note on that. and marketing cost of $35. So we have product development cost. Product development cost, and that is given to be $25. We equally have marketing cost of $35. Marketing cost of $35. When you sum it up, you have it to be $60. If you add the $60 to 65.37, you will have it to be 125.37. That is the revised target cost. So revised target cost. To understand the note 2 better, I will advise you go through my lecture on learning curve. Go through my lecture on learning curve.